Welcome to the video for 3.7 point slope form. This is day A. Point slope form is y minus y1 equals m times x minus x1. Much like in the slope-intercept form, point slope form identifies a point and a slope on the line. So in this case, the point is identified with the little ones on the x and y. So x1, y1 represents the point, a specific point on the line, one of many points on the line. M is your slope, of course, and the plane xy is just one of the infinite points on the line. So the plane x and y will stay in the equation. And if you look down here on this example, you can see that the plane x and y are staying in the equation. All the other spots, the y1, the m, and the x1 are all replaced with numbers. And it's our job in the first set of problems to identify the slope and a point. So the xy are staying in the equation, but the m and the x1, y1 represent a point and the slope. That's why it's called point slope form. So if we compare the equation to y minus y1 equals m times x minus x1, we just have to match them. So m is the number in front of the set of parentheses. So the slope is negative 1/4. The points x1 and y1. So the only thing tricky about finding the x1 and y1 is simply that there is a subtraction in the problem. So this 3 looks negative, but because there is a subtraction in the form, the x value for this point is actually a positive 3. And the same thing for this 4. It looks like it's negative because of the subtraction in there, but the subtraction is part of the problem, so it is actually a positive 4 for the actual point. So I guess what we could think of it as that the x1, y1 will be the opposite of what you actually see in the equation. Continuing on, we're just identifying the slope and a point. So your m is always the number in front of that set of parentheses, and the xy will come from the numbers after the x and after the y, but just the opposite of what's there. So if this is looks like a negative 3, again, this is a positive 3 value. This looks like a negative 1, it's actually a positive 1. In the next problem, slope is 2, and my x value is coming from here. It looks negative, but it's actually positive. This one looks positive, so this is actually a negative 1 for my y value. And the last one, my slope is negative 1/3. That's the number in front of the set of parentheses. And the point, again, is the opposite of what's here. So it looks like my x value is positive. That means my actual x value is negative. And the same thing here, it looks negative, but it's actually positive. So it would be the point -3, 2. Go ahead and pause the video and try these 3 on your own. You are simply identifying the slope and a point. Now go ahead and check your answers, again paying attention to the signs on the x, y values. In the previous lesson, we learned about slope-intercept form, which is y equals mx plus b. And this is important because this is the most common form that we use when we write linear equations. The point slope form that we are learning about in this lesson that you see an example of here is very useful. However, it's also important for us to be able to convert or change this point slope form into slope-intercept form. And it actually only takes a very few number of steps. We'll start by simplifying the right-hand side with a distribution. I can't stress enough the importance of using a calculator for this second. Like the first multiplication isn't really multiplication because you're just multiplying it by a variable. But the second multiplication, you are multiplying two numbers, and in this case specifically, there is a fraction. It is a negative fraction times this -3 here. So that's going to end up being a positive 3/4. Please use your calculator here and try to be consistent by keeping it in fraction form. After this, the only step remaining is to add the 4 to both sides, and that is my last step because at that point I will have y equals mx plus b, and I'm okay to leave my b there as a mixed number. So it's just two steps. We're distributing, and then we're going to add or subtract whatever number, whatever value is over here with y. We just need to move that away. It needs to be moved to the right-hand side. Two steps, distribute and either add or subtract, and we're done. This is slope-intercept form. Let's do a couple more together. Distribution first, then add the 1 to both sides. Just like with solving anything, you have to be really careful with your positives and negatives. Please use your calculator so you're not making little mistakes. Y equals 3x minus 8 would be the slope-intercept form of this point-slope form line. Both of these lines, or both of these equations, would graph the same exact line. They're just different forms. Next problem, distributing first, then subtracting 1 from both sides. Slope-intercept form is y equals 2x minus 3. Last one together here, we have another fraction. So again, please just use your calculator with this distribution. Then we have to add 2 to both sides. Y equals negative 1/3 x plus 1. Go ahead and pause the video and try these 3 on your own. Your answer should be in slope-intercept form. Y equals mx plus b. That's how all of your answers should look. Go ahead and check your answers. The final piece to this lesson is being able to graph the equations that are in point-slope form. And so there are 2 methods to doing this, and the first requires the least amount of work, but you just have to be able to read the point-slope form. So in this case, the slope in this example is -3, and the point that we're going to be using, remember, comes from here. This is going to be the opposite of the +2, the opposite of the +4, and that's going to be the point that I will use. So this point of -2, -4 is on the line. So I'm going to go ahead and I'm going to graph that point. And now that I've plotted that point, I can use the slope. Remember that the slope tells me direction. It tells me rise over run. So when I have a number, when I have the slope is -3, that's actually -3 over 1. So I'm going to go down 3 and to the right 1, and that's how I'm going to get more points on this line. So I'm going to come over here, I'm going to count down 3, 1, 2, 3, to the right 1, and I'm going to put a point. If I continue down in this direction, 1, 2, 3 over 1, I can put one more point there, but then I'm out of space. And so what I want to talk about is also the ability to go in the opposite direction, the other direction. Instead of going down and to the right, I can go up and to the left, and that would still give me my negative line using the slope of -3. So instead of going down and to the right, I'm going to go up and to the left to also give me more points. Once you have your points, and as many points as you could possibly get on the graph is what I would recommend. Once you have those points, you can connect them with a nice straight line. So another example, using this method, I'm going to identify the slope as -5 halves, and then my point would be +3, -4. So I'm going to start by plotting this point, and then I'm going to use the slope of going down 5 and to the right 2 to get more points. So I'm going to come down 5 and then to the right 2 to get more points. I'm going to do that as much as I can, but then I will also go up and to the left, up and to the left, up and to the left again, so I get more points going in on the grid so I can have a nice straight line. So after drawing the points and connecting them with a line, this is the line from this equation, y plus 4 equals -5 halves times x minus 3. If you prefer to graph from slope-intercept form, then you could turn the graph or the function into slope-intercept form first. This would be the second method, and then just graph using the slope-intercept form. So let's first take the 2 steps to turn this point-slope form into slope-intercept form. So the slope-intercept form of this equation is y equals 3x plus 19. And this is a very good first one to come to because it actually shows you why slope-intercept form might not be the best one to choose all the time. Because I have a y-intercept of 19, but my graph, my grid over here only goes up to 10. So that means I'm going to have to change and make it so that every tick mark actually represents a 2. And so in order for me to find the y-intercept of 19, I'm going to have to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and I'm gonna have to put a dot halfway here so that it represents 19. So using slope-intercept form, I'm starting at the y-intercept right there of positive 19. My slope is 3, which as rise over run is 3 over 1, which technically means we should be going up 3 and to the right 1. But as you can see, since we're already at 19, I don't have any room to go up. So instead of going up and to the right, up and to the right, I'm going to go down and to the left, down and to the left, down and to the left, down 3 and over 1, down 3 and over 1. And that's where I'm going to get my points to make sure that I still end up with a positive slope line crossing at positive 19. And before I connect these dots, one thing we also have to keep in mind here as I'm counting with my slope is that because I started at like this half point, I have to count by at that same half point. So 1, 2, 3 over 1. So you see my dot is still in the middle there. 1, 2, 3 over 1. So you just have to be careful with this particular example that since I'm starting in between the grid lines, when I use the slope to bounce count to get more points, I'm going to have to continue with that pattern. So there's the graph of y minus 1 equals 3 times x plus 6, or y equals 3x plus 19. Again, this equation in point slope form would graph the same line if I use the first method as if me just using the second method of turning it into slope-intercept form first. Let's try that second method again with this problem. This second example is definitely smaller numbers. My slope-intercept form is y equals negative 2x plus 1. Again, I got that from distributing and then subtracting 3 from both sides. So this one will be very simple. I don't have to worry about my scale over here at all. I'm just going to come over. I'm going to put a dot at the plus 1. And then a slope of negative 2 means I can go down 2 and to the right 1 to get more and more points. But then to also get points in the other direction, I'm going to go up 2 and to the left 1, and that will continue to give me a negative slope of 2. So that is the graph of the line y plus 3 equals negative 2 times x minus 2 in point slope form, or as slope-intercept form, y equals negative 2x plus 1. Go ahead and try these 4 equations. You are going to be graphing them as it states in the instructions. You can use either method, so please do not feel forced to use both. What you're really going to be checking for is that our graphs look the same. Go ahead and check your answers. Please pause the video to really check your answers here. You can see that I just chose to keep everything as the point slope form, and found the slope and the point that they wanted me to use, especially with these ones with the slopes were fractions. I didn't want to have to multiply that out. Not that that's not possible. And you can see actually all of them from the graphs, it looks like their y-intercepts were all nice y-intercepts. So if you did turn them into slope-intercept form, it should have been fairly simple to graph from there. And technically, having the graph now from the last lesson, you could write the equation for these lines in slope-intercept form also, because you can count the slope and you can find the y-intercept. This concludes the first day video lesson for point slope form. Thanks for watching.